Welcome back, everybody, to our third video of this unit. Today, we are talking about, we're drilling in a little bit more into ways to measure intelligence and how to know if you are intelligent, if the people around you are intelligent, using intelligence tests, which you'll remember we talked about yesterday. We talked about aptitude tests and achievement tests. We talked about the WAIS and different types of tests that people use. Today, we're going to talk about what to do with the results once someone has taken those tests. 536 through 539 in your best friend. And here we go. So first, what makes a good intelligence test? How do I know that a test that I have given or that I have taken is a good one? Well, we've got this thing called the normal curve. You've seen this before briefly in this class, and I'm sure many of you have seen in math classes as well. If you're in AP Stats, for example, you should be well familiar with this curve. The normal curve is a sort of like an ideal distribution of scores along an axis. So here's my x-axis. This is the range of scores. So at this end, as you see me mouse over it, would be 0. I scored a 0 on the test. At this end would be the best possible score. So let's just say that the best possible score is a 5. It's an AP exam. 5 is here. Everybody falls somewhere along this curve. X-axis is score. Y-axis is number of people who achieved that score right here. So you can see that people tend to cluster in the middle, and there tend to be very few people who did horribly and very few people who did extremely well. This is, again, a ideal normal curve. It's shaped like a bell. If you hear the bell curve discussed, same deal, brothers and sisters. The bell curve is developed using a process called standardization. When you standardize something, you give a preset group of people, a small group of people that are representative of your population, the test. Those people take the test, and you compare the range of their scores. And you define what is a meaningful score on an exam using those people's scores. So, for example, let's talk this through using your AP test. You all take the AP test in May. Some people around the country, no one listening to this right now, I'm sure, but some people will totally bomb that AP test. They will get like almost none of the total possible points. Some people will crush it. They will blow that test out of the water. They will get almost all the possible points you could earn. They get no questions wrong. They get all the FRQ points. They do great. Most people will be somewhere in the middle. We figure out where those people in the middle are. We find our median. That's this 0. This is the median, which is the middle number of scores. Then we calculate standard deviations from that. So the first standard deviation is roughly 34% of the people who scored. So the next 34% of the people who scored above the median and below the median. These numbers, guys, you don't need to know exactly. Just know 34. That's fine. You don't need to know the decimal points afterwards. But so roughly 68% of people score within one standard deviation of the median. Roughly 95% of people score within 2 standard deviations of the median. And it gets smaller and smaller from there. +1, this is 1 standard deviation, +2, 2 standard deviations, so on and so forth. The blue lines here are representing each standard deviation. And so your AP Psych gurus who have designed this test, who have administered it, and who are now, it's sometime in the summer, June or July, comparing your answers, will look at this and they'll figure out, okay, so we want to set, let's say we'll have a 3 be the median. We'll have a 4 be roughly 1 standard deviation above the median. So that's our cutoff score for a 4. And our cutoff score for a 5 is roughly 2 standard deviations above the median. This is not exactly how it'll go, but this is just to give you guys an example. This, again, one more time, is our normal curve. It is an ideal looking normal curve. A few other ways we can make sure that our tests are legit, besides if they adhere to the normal curve, to the bell curve, are things called reliability and validity. Reliability is the extent to which a test gives consistent results. So if I take the test today, and then I take the test a week from now, and then I take the test a year from now, are my results going to be the same? If so, it's reliable. There are 2 major ways you can measure reliability. You can split a test in half. This is called split half reliability. and compare half A and half B. And if they give you the same score roughly, then that test has split half reliability. You can also retest, like in the example I just gave. So I take a test and then I take it again a week later, and if my score is the same, that test seems to have retest reliability. Second thing is validity. Validity is the extent to which your test is measuring what the heck it's supposed to measure in the first place. Or is it measuring something else entirely? For example, your AP Psych test is supposed to measure how much you know about psychology. If it measured, let's say it was a terribly designed test, Nemec wrote it, and instead of measuring how much you know about AP Psych, it measures how much you know about human geography, then that test is not valid. Validity, again, can be broken up into two different sort of main types of validity. First is content validity. This is whether the test samples a behavior of interest. This means that as you write a question, are the questions that you write actually testing what you want them to test? Again, if Nemec writes you a question, it's going to test human geography. If I'm writing you a question, it's going to test psychology. So if it has content validity, my psychology question should be on my psychology exam. And predictive validity then is how good a test is at predicting future performance. So you would use some correlation here. You would see, like, let's say people score really well on my test. How do those people do well in the future? Is there a correlation there? And if so, that test has predictive validity. These things are not perfect. They can be messed around with. There's some debate in the scientific community about how reliable and how valid some of the things that we use to test people are. And one thing that's causing that is the Flynn effect. The Flynn effect is this fascinating phenomenon in which, if you look at intelligence test scores going back several decades, the raw score on those, so in other words, if you took an intelligence test now and an 18-year-old in 1990 took it, and a senior in high school in 1980 took it, and a senior in high school in 1970 took it, those tests, the average and median, both of those scores, has been increasing over time. The raw scores have been increasing over time. The distributions have stayed the same. So going back to your normal curve, we still have bell curves on a well-designed intelligence test. But let's say that in 1970, the median score was 50. Today, that median score might be 70. Those scores are going up overall. That is it for how to judge if a test is good or not. Make sure, again, ladies and gents, that you submit a question on Google Classroom so you can get credit for this. We will see you tomorrow. Have a good one.